Hello, everyone. I'm audible. So, fine, guys. I think I'm audible. So, happy Raksha Bandhan to all of you. I'll start with the class. Yes, hello, dear initiative. You are announced on YouTube today. Yeah, thank you. Okay, fine, guys. Let's start. So, I think yesterday I was talking about a theoretical part, a theoretical concept of a linear regression. So, we all have seen that how internally this linear regression works, or any kind of a machine learning algorithm works, and how it will be able to learn, and what is the meaning of learning, right? Like how I will be able to find out a value of m or a value of c, which is nothing but it's a learnable parameter we are trying to learn. We have also seen how we can calculate a delta of e of m, delta of e of c, right, which is going to contribute to update my value of m and c continuously, unless and until I will not be able to reach out a point where residual square will tends to, or derivative of residual square will tends to a zero. So in at that particular point of a time, I can stop my learning, right? So this is something that we have already seen in our yesterday's class. Now in today's class, what we will do is we will try to build a very first model, right? And it is not going to be a tough at all. So it is going to be a very easy for all of us, right? And we all will be able to, I think, do it, right? And I will try to explain this entire things with a very simple data initially, because this is the very first module that we are trying to train, or we are going to develop. But going forward, it is going to be a complex one. So let's try to understand this particular part now. So let me share my screen. Let me try to open up Anaconda prompt. So maybe CD Jupyter. Okay, fine. So let me launch a fresh notebook. And I believe my screen is visible to every one of you, right? Okay, fine, great. Now, so let's try to start typing a code over here, right? And it is going to be a very basic one, very simple one, right? Because this is the very first example that we are going to compile. So let's try to import all the required libraries. So maybe I can try to import pandas as PD, and then I can try to import maybe matplotlib dot pyplot as maybe a plt. Then we can try to import pickle for a model saving. Pandas profiling, we can import maybe a profile report. So okay, so these are the imports that we are going to do, right? Because these are the libraries we are going to use. So maybe I can try to import numpy as well. I don't know whether I'm going to use it or not. Import numpy as np. So yeah, these are the library which I'm going to import, and I think we all are aware about this particular library, right? Okay, now here what we will do is, so after doing this kind of an import, I have already pinged you a code, whatever code is written over here, whatever import I have done. So I have already pinged you in your chat box. You can just copy and paste, and then we can try to take some of the data. So like I said, today we are going to build a very first model, so we will not try to get into a like a heavy use cases. So maybe we can try to take a very small data set and a very simple data set which we all can understand, and then based on that assumptions we can try to build some of the models. So let me share this data set with all of you, right? So here is a data set. Maybe you all can try to download and you all can use it. So let me ping this data set to every one of you. Yeah, so data set is also available, guys, in your chat box, so please try to call. And here I'm just going to write like a pandas dot read csv, right? And then maybe advertisement.csv. So this is the data set that we are going to load. Now as a homework, so I have already prepared one of the data set for all of you. So in your homework, I'm going to give you this data set, which I'll ping you in a later stage, right? So this is the data set I'm going to give you, where we have like a 10,000 number of instances and 14 number of attributes, and even a data definition is given over here, right? So this is something which I'll give you as a homework, but once we'll be able to do these things in our live classes with this basic data set, right? So this is going to give you a lot small like complications in terms of doing some sort of a regression implementation. So we'll try to do these things as a homework. Let's try to focus first of all on this particular data set. So maybe I can try to save this data set inside a data frame, right? And this is a data set about sales and advertisement. So here you will be able to find out that TV is given, radio is given, a newspaper is given, and sales is given. So let's suppose if I'm a person and I'm trying to do some sort of a sales, so I'll try to do a different kind of advertisement. So maybe I will go ahead with a TV advertisement, or a radio advertisement, or maybe a newspaper advertisement. And based out of those ads which I'm going to run over a TV, radio, or newspaper, maybe I'll try to do some sort of a sales. So we all know that yes, if we are going to do a more and more advertisement, right, so my sales are going to increase. But the problem over here is that all this medium of advertisement is not going to be effective in the similar manner. So maybe if I'm doing a TV advertisement, it is going to be a more effective as compared to a radio, or maybe newspaper advertisement is going to be more effective as compared to radio or TV. I don't know. So maybe I can look into a data set. I can try to understand all of those things. There is a possibility, there is a chances. So I'll try to understand all of these things. There is no issue at all. So here is a data set which we are going to consider, a data set which I'm going to give you for a homework, right? So this is a predictive maintenance data set. And again, it's a very new data set that you will be able to see. And it's a real data set that you will be able to find out inside a UCI repository. I'll send you a link, don't worry. So I'll give you a link of this data set, which you have to like a solve, or you have to do, or you have to build your model after this particular class, just for your practice. Yes. And I'll tell you what and all things you have to implement on top of this one. Don't worry. Okay. So this is a data set that we are going to use, a very small and a very simple one. Now what I will do is, so I'm looking for maybe some sort of a statistics over to a data set. So no issue. I'll try to do some sort of operations. And yes, we all know that if I'm looking for maybe a first 5 record, so I can try to do data frame dot head. It is going to show me a first 5 record. Maybe I can try to do a tail operation, and in this way it is going to give me a last 5, right? Or maybe if I'm looking for a 10 number of records, so yes, I will be able to see a 10 number of records. But just by looking into a data set, I'm not able to see like a some sort of a result on which I can draw a conclusion, right? I have to draw a conclusion. Someone has told me that, okay, can you please build a model, right? Can you please build a model, so that if I'm like trying to invest this much on TV, this much on radio, and this much of newspaper, then what will be a number of sales, or what will be a kind of a sales I will be able to do? That's my problem statement. That's my original problem statement, right? So someone has told me that, okay, build a model which can try to predict a sales part when this one, and this one is given to me. This is a question number 1. Question number 2 is that, let's suppose if I'm trying to make some sort of an investment on TV advertisement, radio advertisement, newspaper advertisement, then tell me that which mode of advertisement is going to be effective. Let's suppose my radio advertisement is not that effective. In that case, what will happen? I'm not supposed to do some sort of an investment over there, right? It's a wastage of the investment, the kind of a money which I'm going to invest maybe on a radio advertisement, right? And if it is not going to give me a return, or maybe unvisible returns, or maybe sales, if it is going to give me, in that case, I will not consider, I'll not do an investment on a radio. So this is a question number 2 that someone has asked me. Someone has asked me that, okay, so is it possible to define some sort of a relations? So if relations are possible, then yes, derive those relations. Means whether this data set is showing me a linear relations or maybe a non-linear relation. If it is linear, then only we can try to implement a linear regression. Otherwise, again, there is no possibility, there is no chances that I will end up implementing a linear regression. So these are the questions that I have, and we have to find out an answer for all of these questions one by one, a step by step manner. So fine, let's try to do it. And finally, we have to build a model. After building a model, so we have to do a deployment of the model, maybe with respect to some UI devices, maybe with respect to some Windows widgets, or some of the offline applications, so where people can feed information, and then I will be able to get a final prediction. So these are the questions. So we have so many questions and we need an answer out of each and everything. Even we have to check that whether this data set is showing me some kind of like a multi-collinearity property, or some other like relations or variations in between errors or something. So all those questions we'll try to understand and we'll try to identify one by one. So let's try to understand, guys. So what I can do is, so let's suppose if I'm looking for an statistics of this particular like a data set, relations statistics, what do you think, what we should do in this case? So anyone, any suggestions? I'm just looking for maybe a statistics or maybe a relationship between a data set. So anyone who can help me with that? Okay, someone is saying that data frame dot describe. Okay, but describe is not going to give me many results, right? Maybe I can do that. So data frame dot desc, right? I can try to call. That is completely fine. But we all know what I will be able to see, or what I will be able to get out of the describe. Count, mean, standard deviations, 25 percentile, 50th percentile, 75th percentile, or maybe a maximum. These are the things which I will be able to see. And yes, it is helpful, but not much. So here, yes, I can observe how many null values we have. So it looks like there is no null values, right? In every column, we have 200 200 200 records. Okay, now here, so average wise, so average TV ad expense is $147, let's suppose. Radio expense is $23, and a newspaper expense is $30, and sales is equal to $14. Standard deviation is equal to 5 for a sales, and a minimum that I'm going to spend on a TV is equal to 0.70, on radio is equal to 0, and on newspaper is equal to 30. It says me that, okay, at any point of a time we are spending more on TV as compared to maybe a radio and a newspaper, right? Okay, so again, maximum. So these are the only details which I will be able to observe out of these things. So maybe what I can do is, so I can try to call a pandas profiling, right? You already know about pandas profiling. We all have done that, right? So if I have to like call a pandas profiling, okay, so what we can do, so maybe we can try to call in this way. So profile report, we can try to pass our data frame over here, right? And maybe we can try to execute it. Let's see what happens, right? So let's see what kind of reports I will be able to get out of this pandas profiling. Yeah, so I think we all are aware about, right, this kind of a reports, where it is going to give you a reports of each and every kind of a relations, and whatever kind of relations we are not even able to think of. So maybe I will be able to see even those kind of reports over here. Maybe if I have to showcase each and everything in a beautiful manner, so what I will do is I can try to save these things in a variable. So let's suppose this is a variable called as pf profile variable, and pf dot to widgets I can try to call to widgets pf. Yeah, so again, this is going to give you a same result, not a different one, but maybe in a structured manner you will be able to see a result. Yeah, okay, so it's the same report, but maybe in an interactive way, this reports I'm able to see. Just I'm trying to call this profile dot two widgets, right? So just in a widgets format, I will be able to see each and everything. Okay. So number of variable is equal to 5, right? Numeric is equal to 5. Number of observation is equal to 200. Missing cell is equal to 0. Missing cell is equal to 0. Duplicate is equal to 0, right? Total size in memory is very less. It's like 4 KB. Average record size in the memory is equal to 40 bytes. Now, warning wise, so is highly correlated with sales. So yes, to find out these things, right? To find out these things, we try to do a correlation plot. Yes, everyone. So we always try to do what? We try to find out our correlation coefficient. We always try to find out. And based on those numbers, correlation coefficient number, so we say that okay, whether it's a highly correlated or whether it's a less correlated. But here, right? So here, maybe we can do a scatter plot. Maybe we can try to draw maybe a heat map or something. And based out of that, so we can try to find out these things. But if we have a pandas profiling, and we all know, right, in a backend how it is working, we all know about it, right? It is calling the same thing, your correlations. So here, without even writing a single line of a code, TV is highly correlated with sales. Okay, fine. So TV is showing me some sort of a relations. Radio is highly correlated with sales. Sales is highly correlated with TV and one others. Okay, TV is highly correlated with sales, radio is highly correlated with this one, right? So fine, this is something that I'm able to get. This unnamed column, so if I'll show you my data frame, this is my data frame. So we have this unnamed column where I have 1 2 3 4 5 6 kind of a indexing. So this one is uniformly distributed, so it is not showing you any sort of a relations, right? This one has a unique value, so fine, like we have just an index over here. So again, this is of no use. Nowhere I'm able to see that it is showing me or it is saying me that okay, fine, so this is related to this one. So pandas profiling is like going to give you a beautiful report, and without applying like much of effort over here, I will be able to see my answer that yes, there is some relations. If it is telling me that okay, fine, so TV is related to a sales, radio is related to a sales, right? So yes, I can believe on this one, and maybe I can say that yes, this is like a effective one, right? Are we able to find out a newspaper somewhere? No, right? But we had a newspaper column, right? If you will observe over here, so can I say that we have a newspaper? Yes, we have a newspaper, but nowhere in my report I'm able to see that it is trying to relate this one with a newspaper, right? So yes, maybe like it's not correlated or something, right? We'll try to figure it out, no issue. But yes, nowhere I'm able to find out these things. Now, so analysis started this one, duration is 3.48 seconds, which is very, very low. It's completely fine, right? And then maybe a variable. So there is a variable column called as unnamed column. So we are not supposed to worry about this one because it's completely fine, right? So like this is just an index column that we have. So we are supposed to worry about a TV, radio, newspaper, and sales. So fine, I'll try to expand this TV and highly correlated, right? Distinct value is equal to 190. So there are total like a 190 different kind of a ad maybe I have executed, or maybe kind of a expense I have done. Distinct is 95%, there is no missing. Infinite is equal to 0. Average is equal to 147. We have already seen that, right? Even from here, from my describe column. So yes, I was able to get the same report over here. So yes, a same thing I'm able to observe even in this particular place. Minimum is 0.7, maximum it's completely fine. Negative memory size is equal to this one. Toggle details. So here I can try to observe even a reports in more detailed way, right? A same report which I was able to get from a describe function. So same report I'm able to see even over here. Standard deviations, correlation, coefficient of the variance, kurtosis, mean, skewness. So everything we are able to observe over here. Now here I will be able to find out that whether my data set is normally distributed or not without doing anything. Common values, so that is also fine. Extreme values, so what is maximum, what is minimum, so everything I will be able to find out. Again, if I'll talk about an interaction, so maybe a TV, right, with a sales. So TV with sales, this is the relations without doing anything, right? I'm able to see a graph. So TV with sales. So how TV and sales is related? For sure, you can write one line of a code for doing this scatter plot kind of a things. But why to do that? We are already aware about it, right? So why to do those kind of operations when we have a pandas profiling? So it's better to go ahead with pandas profiling. Why to write even a two-line, three-line of code when we can do it just in one line? Yeah. Okay. So here, yes, there is a relations. I'm able to find out if TV is going to here, if I'm going to increase advertisement cost, yes, my sales is increasing, right? So this is something which I am able to observe. So there is a positive relations which I'm able to find out. Maybe I can say a TV with or maybe radio with sales, right? So radio with sales, so yes, if I'm going to invest more and more on radio, right, in between this to this range, so yes, my sales are increasing. Maybe I can do a newspaper versus sales, right? In case of newspaper versus sale, are we able to see some robust relations over here? I don't think so, right? It's just like a scattered one, right? So this one is not showing me any kind of a relation, and that is the reason. So if you remember, it has, so when pandas profiling has mentioned that TV was highly correlated with sales, radio is highly correlated with sales, but here in this case newspapers is not correlated with the sales, and I think we all are able to see that information over here, that newspaper is not correlated with a sales, right? So this is a very good observation that we are able to see, right? So maybe for a certain range somewhere, if we are going to do some sort of an investment, right, maybe in between this to this range, so yes, it is going to show you some result, but still if I'll talk about this data set or maybe this data set, so although I'm trying to increase investment, but still my sales is not increasing, right? It's not going high. Maybe for this data set it's true, but for this data set or for this data set this is not true. So again, this is not correlated at all in between any kind of a range. Now if I have to check a multicollinearity, how I will be able to check a multicollinearity? Through a graph. It's just a random one, right? This relation is just a random relations, you will be able to find out. So there is no such correlations you are able to see over here. Simple. So here, if I have to observe that whether TV and radio are correlated or not, which is called as what? What is the meaning of multicollinearity, by the way? I think yesterday we have discussed about it, right? So if there is a relationship between a feature variable itself, that is something called as multicollinearity, right? So for example, if I have x1 column, if I have x2 column, if I have x3 column, if I have x4 column, and if I have y column, right? So x1, x2, x3, x4 is called as feature column, and this one is called as a label column, you can say, right? Okay. Now here, if there is some relationship you have in between a feature column itself, right? If there is some relationship you have in between a feature column, that property is called as multicollinearity. So in case of multicollinearity, right? So for sure, if I'll try to plot a graph, this versus this, I will be able to find out that whether there is some multicollinearity or not in between these two variables. There are other ways as well, which I'll discuss going forward, but this is one of the initial way as per our previous knowledge, right? So, okay, here, this, if there is a relationship. Now, what is a reason behind taking a non-multicollinear data? We always say that we are not supposed to consider a multicollinear data. We are always supposed to take a non-multicollinear data. we have to remove a multicollinearity at any point of a time. What is the reason behind that one? I'll tell you what is the reason. So for example, let's try to take one data set. So here 1, 2, 3, 4, right? And now here, let's suppose a 2, 4, 6, and 8. Can I say that this two data set is multicollinear? Means one data set I can represent in terms of other data set. So if I'll say x2 is equal to 2 of x1, is it true? Yes, it is going to be a true, right? So if my data set is multicollinear, if both the columns are showing a same result, right? And again, what will happen is, so when I will try to train my model, so it will start learning, or it will start adjusting a relationship in between a data set itself, which we are not supposed to do. We are supposed to learn a relationship between what? Feature and a label. We are not supposed to, we are not here to learn a relationship between feature and feature and a label. This is our primary objective, right? But if there is a data set which is multicollinear, which is having a relations, so at the time of adjustment of your coefficient parameter or a learnable parameter, there is a very high chances that it is going to produce a biases, and it will end up learning a relationship between your data set, means a feature column itself. And again, so one thing I can try to represent in other things as well, so it is not going to show me some different relations. That relation is already available, and again, there is no need of inclusion of multiple columns which is showing me a same relations, right? Because it is going to affect your relationship between feature and a label. So we are not supposed to consider any kind of a data set which is showing you a multicollinear relations, right? And multicollinear is nothing but relationship between feature and feature itself. Okay, so can I say that TV versus radio, when I'm trying to draw, this one is multicollinear? Yes or no? No? A big no, right? Because this is the scatter, like a complete random graph I'm able to see in front of me. So can I say that TV and radio is not a multicollinear one? Yes, it's a complete random graph that I'm able to generate. Fine, no issue. We can try to check TV versus newspaper. So what about TV versus newspaper? So again, no, right? Kind of a random one. There is no kind of no relations. Means this kind of relation I'm not able to see. This is a like a relations, right? So here I'm able to see some sort of a linear relations, but TV versus radio or TV versus newspaper, over there, I was not able to see any kind of relation. So can I say that I do not have a multicollinear data? So this data set is good to go. Yeah. So we can maybe try to go ahead with this particular data set. I can make this kind of a decision at least, right? So this kind of a decision. So multicollinearity factor is checked already. Again, there is something called as a VIF, variance inflation factor. I'll tell you. So even with respect to like mathematically, you can try to plot a values, and even graphically, you can prove the same thing. So same thing can be done in multiple ways, right? So this is just one of the way, right? So maybe radio versus newspaper, right? Newspaper versus radio. So again, this is a random walk, I can say. Yes. So this is just a random walk. Fine. So there is no multicollinearity which I am able to see in this particular places. Now correlation, right? So again, a Pearson test, or maybe a Spearman test, or maybe Kendall test, or Fick test, right? So we can try to perform, and by which I will get to know about a correlations between a different kind of a data set that we have. So I think we all are aware about a correlation coefficient. So this is something that you will be able to see easily. Now here, right? So what is this like a Pearson correlation? So it's nothing but it always gives you a correlation coefficient R is measurement of the linear correlation between two variable. So it always lies in between -1 to +1. -1 indicates that it is having a negative relation, right? So I have given you already an example. So sales of ice cream in a winter season. So sales of winter will increase, sales of ice cream will decrease. So it's a negative correlation. There is a relation, but it's a -1, right? Sales of umbrella in a rainy season. So rainy season, rain will increase, and then your sales of umbrella will also increase. So that is something called as positive correlations, right? Now, so there is a neutral correlations you will be able to find out, means there should not be any kind of dependency. I can try to give one example over here. So maybe sales of a TV versus maybe a season, any kind of a season. So it doesn't matter what will be the like whether it's a summer season or something, but TV sales will not be related to a seasons. Maybe TV sales I can try to relate with the price, or maybe some festive season. Yes, or maybe your exam. Yeah. So one person has given me exam, that exam. So yeah. So fine. This is something Pearson correlation is going to tell you, right? So yes, if there is a values which is a negative, which is like a two negative, so in that case there is a relations, there is like a negative relations you will be able to find out. And if there is a positive, so it is going to give you a value closer to +1. This is something that you all will be able to find out. So it just show you like relations, that's it, nothing else, one versus another. So it is going to show you that kind of a relations at any point of a time. So here, yes, so TV versus sales, you will be able to find out what is the relations that it is going to give you. Or maybe a TV versus like the radio, what is the relations, TV versus TB, what is the relation. So again, TV versus like a unnamed column. So this is just going to plot that particular graph. So everywhere you will be able to see almost like a similar kind of a graph, right? Just it's a different kind of a plot. Missing value is an important factor. So missing values, do we have any kind of a missing values? So no, we do not have any kind of a missing values. Even I can try to draw the matrices, which tells me that okay, fine, so there is no missing value, so we are not supposed to do any sort of a imputation. Sampling of the data, so yes, these are the head and tail of the data we are able to see. Maybe just for some sort of overview or something, so I can try to look into these things. So this is a detailed analysis of a data set we are able to receive. So it's the same kind of a relations, right? Same kind of a relations that we were able to receive with respect to this one. And yes, we are able to see those kind of a detail with respect to each and every columns. Okay. So now we are like pretty much sure that, okay, there is a relationship between sales and radio and sales and TV. So maybe we are good to go ahead with the like building some sort of a models or doing some sort of operations. If I would like to save this report, so yes, I can try to save this particular report. So maybe I can try to call PF. PF is a pandas profiling variable that I have created. And maybe I can try to write pf.to_file, and we can try to save this report for our later purposes in HTML. Yeah. So yes, it has saved all of this report. So test.html. So yeah, at any point of a time, if I would like to publish it, or if I would like to showcase this kind of a report for any kind of a data set, I have a up and running dashboard. We generally do a dashboarding things, right? Or we generally like perform different kind of operations, and we try to showcase each and everything, right? So this is a beautiful report that we already have, right? And yes, we can try to render it. So whenever we have to showcase some of the result, or maybe if I'm trying to build some of the things, so maybe we can try to render this direct page itself once we are able to save it, and anyone will be able to see this beautiful report, a beautiful automated report, right? Easily, any one of us. So that is completely fine. This report is generated. So going forward, it is my strict instruction to all of you. So like classes, objects, methods, logging, try catch, exceptions, all those things are mandatory. So whenever you are working on a machine learning problem, or whenever you are working with any kind of a data set, right? So always try to generate this kind of a report and save it in some of the HTML page and render it in a later stage, so that users will be able to see. Then again, so after making some sort of a changes into a data set, generate again another report, right? And then showcase to a user, so that user will be able to do a comparison that, okay, fine, so these are the changes which I have made in terms of a data, and this is the detailed description. And you won't have to write even a line of a code to create this HTML page, because by default you are able to get this HTML page. So you're not supposed to be creative over here in terms of creating some sort of a UI UX. Automatically anyone will be able to see it. Yes. So I think this one is the beautiful one, right? Okay. Okay. So fine, these are the reports that we all are able to save, we all are able to generate, right? Now, what is next? Let's try to understand. So the next thing is, once we are able to see like some sort of a observation, some sort of a reporting things, right? Maybe we will try to build a very first model, a basic model, I believe we can try to build. So how to build a model? So to build a model, right? So we have to like take care of certain things. So we have to select our feature and we have to select our label. So which one is going to like be a X column and which one is going to be a Y column, right? And based on that, maybe we can try to build it. So can I say that I can try to first of all build a model between TV and sales? Yes. Okay. So just a basic model, right? I can consider all of these three columns. There is no issue. Means TV, radio, newspaper versus sale, right? That is fine. But as we are trying to build a very first model in our very first class of this practical things in machine learning, right? So maybe we can try to go ahead with the basic one. Okay. So fine. This is my data, right? This is my data set. Maybe I'll try to select what? I'll try to select just a TV and a sales column, right? So these are the columns which I can try to select, and then based out of that, I can try to build a model. So here, X value wise or X column wise, I can try to select data frame of maybe a TV, right? So data frame of TV. So this is a TV column that we have, right? This is the TV column that we already have over here. And then we can try to select what? We can try to select Y is equal to maybe data frame dot sales, right? So this is the Y data that we have. So we have a X data, we have a Y data, right? Just like weight and height, if you remember. So weight and height is something that we have taken at the time of so same thing we are just trying to replicate over here. So whatever we have learned in our theory class, right? A simple relation between weight and height. So here, simple relationship between TV and sales. And we are pretty much sure that how TV is like a TV data set is varying with respect to a sales data. So we all are aware about it, right? So now what I can do is, so maybe we can try to build a model. Now to build a model, so can I say that we have to find out the value of M and C? We have to like update a value of this M and C continuously, or we are looking for this kind of a equation. So here, sales is equal to M times TV plus C. So can I say that this is the equation which I am expecting, right? Y is equal to mx plus c. X is nothing but my TV. Y is nothing but my sales. I have to find out a value of M and C. So it's the same things what we have learned, right? Theoretically, height and weight. So the same relations we are trying to establish. We are not getting into a complex relation at all, right? Okay. So if we have to build this kind of a like a relation, so I'm looking for M and C. We have 200 data, right? So it's practically impossible to like take one by one TV and like sales, and then try to find out the next value of M and keep on finding out next value of M unless and until we are not able to converge, or we are not able to reach out to a minima point as per our yesterday's detailed discussion, right? Practically it's not possible. Yes, maybe if we are going to spend a whole day just on doing a calculation, we can do it manually. There is no issue, right? Okay, so what we will do is, so maybe if we have a 200 records, and going forward in this data set, I'm going to give you 10,000 records, right? So in case of 10,000, again, it is going to be a very complex one. So I just have to do a calculation, right? So some mathematical calculation I just have to do. So maybe what I can do over here is we can try to use some of the libraries. Now, library wise, right? Library wise, so there are so many different kind of libraries you will be able to use, where people have already written each and every function. So whatever mathematically, whatever things we have learned mathematically, each and everything is already implemented over there. Such kind of a, so there is one such kind of a library called as scikit-learn, sklearn, right? Even TensorFlow you can try to use, even PyTorch you can try to use, even MXNet you can try to use, even DL4j you can try to use, even Spark ML you can try to use, even Spark ML lib you can try to use. So there are so many different kind of a libraries which is already available, where people have just wrapped up each and every mathematical operations as a function, right? So they have already done a coding on each and everything for you. Just have to pass a data and you will be able to get a result. But if you are looking for some sort of a modification in a original code, even that can be done. I'll show you how, right? I'll show you that particular part as well. So first of all, what I will do is, so maybe we can try to call from sklearn, right? So from sklearn dot, I can try to call a linear model, right? So we can try to import maybe a linear regression. So inside sklearn, you will be able to find out a multiple different kind of a model for a clustering, for anything that you are looking for dummy variable trap, for a Gaussian distribution, for everything, you will be able to find out a model inside sklearn. So sklearn is nothing but it's a library. It's a library which is an open source library available to all of us. I think my screen is visible, right? Clearly? Yes. Okay. So sklearn is nothing but it's just a library. Now, if you would like to see an official documentation of sklearn, so if you would like to see an official documentation of sklearn, so yes, that is also possible. So sklearn, and you can just try to search, and here you will be able to find out each and everything. So, and that too in a very detailed way for any kind of algorithm you are going to learn, right? This is a best place to get an original documentation instead of going through any like articles. What I always prefer is to go through sklearn documentation, the way they have written each and everything. It's a beautiful one, right? For example, if I'm trying to learn maybe a regression, so I can click on regressions, and here, so you will be able to find out like a detail about regressions, right? And again, different kind of algorithms that you can try to use, different kind of a method that you can try to use to solve a regression problem. If you're looking for maybe just a linear regression, so you can even try to search for this one. Sklearn linear model, right? So you can try to do a direct search over here, linear model, import regression, and direct official documentation of a linear regression. You will be able to find out what is the kind of a parameter that you can give, what is the attributes, how to do implementations, right? Each and everything in very detail, you all will be able to find out how like a score will be calculated. Yesterday we were talking about the R square statistics, right? So R square is nothing but 1 minus RSS divided by TSS. So residual summation of a square divided by a total summation of a square. Everything is given to you in a beautiful manner, right? Everything. So always try to refer official documentation. So instead of referring any like articles, this is my advice. I always like advice in this way that, okay, fine. So everything and all the updates you will be able to find out over here. If I'll go and click on source, right? So here you will be able to see original implementation or original code as well. I was talking about this one, right? I was talking about that you can try to make a changes. So again, if someone has written a code, right? And like in terms of like a classes and functions, and it's always a better idea if you would like to like get a expertise, right? A super expertise to build any kind of a product or to write any kind of a library by yourself. Always believe me, don't look into any like a I would say Stack Overflow or something, right? Always look into an official GitHub repo of any development, right? So sklearn is a big library that someone has created, and again, classes and object and functions, that's the only thing. Someone has written, right? We all are aware about classes, objects, keyword, argument, arcs, and everything. So we can try to explore these things, and you can check how class for linear regression is written in your final project, the project that we are going to do. In a similar way, we have built a library for even those projects. And what is the meaning of what in very detail in as a doc string, you will be able to find it. I think we all know how to write a doc string. We all have studied these kind of things in our classes, right? What is the attribute it is trying to take, and how to write a standard code. Even you will be able to educate yourself, right, in a way that how to write a standard code. And that is the reason. So even in my internship, when I have launched an internship, I have given instruction that this is a instruction, bare minimum instruction you all have to follow to write even a single line of a code. Writing code is not a big deal, right? But you have to write in a modular fashion, a scalable fashion, so that other person will be able to make some changes. So how to write a standard code? The best way to learn all of those things is to look into this kind of implementation. Maybe a Sklearn, maybe TensorFlow, maybe Keras, maybe PyTorch, maybe MXNet, maybe DL4j, maybe Cafe, right? So in any of this official implementation, you will be having like enough amount of chances, and then try to learn, try to understand that, okay, how they are writing like a standard code. And it's nothing you all will be able to understand, because we all are aware about these things. If I'll ask you, can you please explain me these things, you all will be able to explain that we are trying to pass a value of an intercept, normalize, copy x job, number of job that we can run in a parallel thread, and positive values, and then it's done. It is going to initialize this value for a particular classes, and then this is there is a function called as fit, so which will try to start like doing a learning by taking maybe x and y values over here, right? So every kind of implementation. So it's not like your libraries you are going to call, like I'm going to call this linear regression, I'm going to pass my x and y feature and labels, right? So, and again, you will be able to get a model. For example, I'll show you, right? So what I will do is, so I'll just try to like pass a data. So I'll try to call this linear regression, right? Linear regression I'm going to call, and then I'm going to pass maybe data over here, x comma y. I believe this is my variable. Yes, x comma y is a variable which I'm going to pass over here, right? And I can try to, maybe I can try to save it. linear, let's suppose, in this variable, right? And then we can try to call, right? So linear dot fit. Now this fit is nothing but it's basically a method, or I can try to remove, this is just an object we can create, and here we can try to pass a data x comma y. So here value error, okay, expected 2D got 1D instead. Okay, no issue. So I can try to make it 2D. Okay, so linear dot fit. Now this is a linear regression class. So I'm trying to create an object of this what? Linear regression class. Now what is this class? Here is the class, right? So here is the class that I have, and I have already created the object. Now inside this class, right? So inside this class, init method is written. That is fine, right? Fit method is written. So I'm supposed to call what? I'm supposed to call a fit method, so that I will be able to do a training, because inside a fit method, you will be able to find out that this entire training steps is written. Complete training steps is written over here inside a fit method itself, right? So here, right here, we are going to call a fit method, and training will be done. Now this is going to give you, right? So this is going to give you a final like models. So now here, now when I'm going to call linear dot fit, means this class object dot fit, my model is done. Now what is the meaning of model is done? Meaning of model is done means I'm able to find out the value of m and c, right? So I'm able to find out the value of m and c. Now how I will be able to see what is the value of m and c, what kind of an equation it has built? Now someone is saying that we did not split our data set. That's not required. Nowhere it's written that you have to do a train and test split. I'll do it in a later stage, right? First of all, We are just trying to do whatever we have done in our theoretical classes. Yes, I know some of you are like educated people who know how to build a model, right? By doing train test split, random variable changes, by doing some sort of a standard scaling, right? By doing some sort of imputations. But I'll try to, first of all, do those things which I have discussed in my theoretical classes. Then the standard approach we will try to follow. Is it fine to everyone? Yes. So we'll do all those things. There is no issue, but it's not mandatory. This is what I'm trying to show you. Yes. Okay. So linear dot fit. When we are trying to call fit, so fit is nothing but it's a standard method you will be able to find out, which is trying to call a training. Now, what is the meaning of training? Same thing that we have learned yesterday. Finding out a best possible value of M and C. Right? So now how I will get to know what is the equation, what is the value of M and C. So yesterday I have asked you to do a calculation of M and C, and even a changed value of M and C you all have calculated, right? By considering delta of E of M, delta of E of C, right? You all have done that. Again, same thing this fit method is doing, just in one line. We are able to find out the optimal value of M and C, right? So now let's try to understand what is the actual value of M and C we are able to get, or we are able to see. Okay, so this object linear, for this object we have built it, right? So maybe we can try to call intercept. Now, what is the meaning of intercept, by the way? What is the meaning of intercept? Can I say intercept is nothing but it's a C value I'm talking about, right? Okay, and now so I'll try to call linear, right? Same object dot maybe coefficient. What is the meaning of coefficient? Can I say M? Yes. So what will be my equation? What will be my equation? So if I have to write sales is equal to M times TV plus C, right? So can I write this equation in this way? 0.0475 times TV plus 7.03 is equal to sales. Now, if I'll ask you that, okay, if I'm going to spend $10 on TV advertisement, then what will be a sales? Is it possible to do a calculation now? Yes, it's possible to do a calculation. So can I say that we are in a position to like do some sort of predictions based out of that? And can I say that I think this is the same thing we were trying to achieve even in our height and weight example. Exact same thing. Theoretically, we all have understood. We all have learned, right? Exact same thing. There is no other differences. We were able to find out, right? So here, yeah, 7.543 or 7.5 will be approximately a sales if TV is going to be, if I'm going to invest $10 on a TV. So this one will be the sales I will be able to see. So now for any inputs, yes, I will be able to do a prediction. This is the equations which I was expecting. And yes, it's done just by using one single line. This is the only line which is required. Nothing else is required to build a model. If everything is fine with respect to my data set. Yeah. So this is like a model. I can save this model. I'll talk about it, right? But before that, let's try to understand what is there inside fit, right? So when I'm calling fit, it is going to call all the mathematical explanation that we have taken, that we have discussed in yesterday's class. Everything is done inside the fit. Someone has already written this function for me, right? Inside this linear regression class. Right now, so this is not a black box. It's not like this fit is something like a black box. I can't see it. We are just calling. How many of you are like calling this fit method without knowing a fact what is written inside fit? I think everyone. Right? We never even taken this kind of a pain to go and check what is happening inside fit. Right? Let's suppose I have to change something. Maybe I have to like change how it is going to initialize the initial values, right? And all those things. Let's suppose if I have to change, can I say I can change it? Because it's just a class which I'm trying to call, right? And we all know how to call a classes and modules. We all have studied it, right? So here what we can do is, so maybe if I have to change something, some of the inbuilt values, right? So for example, I'll just tell you. So here it is trying to take multiple parameters, right? So fit intercept, normalized, right? Or maybe copy X number of job it is going to execute for a computation, for a parallel threading, positive values, true or false, right? So let's suppose if I have to change some of the parameter, maybe I'm not liking this parameter, I have to change this library, right? So I have to change these things according to me. Maybe they have written over here that try to call, right? Try to call this coefficient underscore to get a coefficient, but I'm not liking this convention, I'm not liking this name. Yeah, I would like to change this name. Yes, I would like to change this name. So in that case, what I should do? Nothing. I'll just try to copy this class and I'll make the changes in all the variables. My work is done, right? In original code itself, we can try to change, and everything we will be able to understand. If you'll start reading out each and everything, right? You will feel like just a story that you're trying to read out, right? So anything can be done, and any controls you will be able to get. It's not a black box at all. It's not at all a black box, right? So we can do anything over here, and we can, if I'm looking for some sort of optimizations or any other matrices which I'm supposed to give over here. So yes, I will be able to do each and everything inside this one. Yes. So what I'm expecting from all of you is try to study this one as well. It's not tough to understand. It's easy to understand, right? So once you will try to go through each and every line one by one, as we all understand our classes and object concept, right? And we understand even this one, what happens internally or how everything will be calculated. So we understand both the part. So in this case, these things easily we can try to understand, not only just for this equation or this algorithm, even for each and every algorithms, you will be able to find out. Now, someone is asking me that what yesterday I have seen some of the questions. I think there was one person who has asked me a question that how initial value of M will be given, right? Or how initial value of M will be assigned. Now here is a answer that you have. So it depends upon a different kind of a libraries. If I'm not liking this kind of a weight initialization, in that case, what I will do, I'll try to go ahead with the my own weight initialization, or maybe a random weight initialization, or maybe just by taking two random sample, I'll try to calculate the initial value of M and C. So depends upon me how I'm going to modify all of these libraries, so I can try to check, or I can try to perform each and every kind of a operations, and everything is possible, right? So here, if sample weight is none, sample weight is np dot ones. I think we all understand what is the meaning of numpy dot ones, right? So n number of sample weights it is going to assign, and then this is the procedure it is going to follow in else condition, right? So this is something that you also check, and then at least try to call your fit method, right? Now here, let's suppose I have a use case where I'm asking you that in each and every step, what is a value or what is the changes system is trying to do. So if you can show it to me, again, answer you will be able to find out even from here. So every time, so we are trying to update our weights, right? So we are trying to update our weights. We are trying to fit our intercept over here each and every time. So every time we are trying to change the value of this one, value of the intercept we are trying to change, or value of your coefficient we are trying to change. So yes, maybe I can try to write one function over here which will keep on capturing each and every changes, or keep on writing each and every changes in some of the doc file. In this way, from which value of M and C it has started, and what is the final value anyhow we are able to see, right? And what is the final value I am able to get, each and every steps you will be able to find out. And this procedure is very easy in tensor board. So in TensorBoard, this is already like applicable. So by default, TensorBoard captures all of those things if you're going to integrate a TensorBoard in your deep learning implementation, right? And each and everything you will be able to visualize, and you will be able to see in very detailed way, that too with every changes and every step that system is going to take internally. That is possible in scikit-learn. So it's not mentioned as of now, but that is possible, because at the end of the day we are updating our variables, and if we are updating our variables, so yes, they can capture it, right? Please ping a GitHub doc link. Please try to find out by yourself. I have already shown you how to find out. Don't expect every kind of a ping in your chat box if you are like attending a classes. Okay, now here, right? So here we are trying to like do some sort of a fit, and yes, fit is done. We are able to build a model. We are able to like find out what is the intercept or what is a coefficient, right? So these things we are able to find out. Means now we are able to get a equation, y is equal to mx plus c. So yes, y is equal to mx plus c, that is the equations we are able to find out, and we all are able to get. There is no issue at all, right, with respect to these things. Now the next thing is, so maybe I can try to check what is the accuracy of the model, right? Next thing maybe I'll try to pass a values, I'll try to do some sort of a prediction, or maybe I'll try to like save this model so that I can share this particular model with all of you. And without building this model, you will be able to do testing, you will be able to do a prediction, right? So there are so many tasks you will be able to find out. As of now, we have done a very, very small task, just 1-2% of the whole task. 98% is still left, right? In terms of, and there are so many other things which will come in between if I'll try to include a ops part in this one, ops and deployment part. So here, what we can do is, so I think till this point we are clear, right? So what is the meaning of this fit operation? Because in next algorithm, I'm not going to explain you these things. I'll just use it directly. Can we see what's the value of delta E and delta EC at last? No. So that's the reason. So I told you, you have to do a modifications over here in this library, because every value is going to change, and you will be able to capture it if you are going to override this particular class. Okay, fine. Now moving ahead, right? So what I will do is, so I have already created a equation, right? I've already created an equation y is equal to mx plus c. I'll try to save it. I'll try to save this particular model, right? Now, what is the meaning of model? Y is equal to mx plus c, this equation with value of m and c. If I'm going to save it, so that is something called as model. Model is a physical file, right? So I can try to like write y is equal to mx plus c with m and c values in any of the files. So fine, let's try to like write it. So here maybe I can try to like create a file. File name is equal to, I can give linear, right, regression.sav. This is nothing but it's a bytecode format. SAV is just a bytecode format. And then if you remember, I have called pickle. This pickle is nothing but it's a serializable file format. Even in pandas, I believe we all have studied about this pickle format. This is just one of the file formats. So maybe I can try to call. So I have this object. This is the object which I have trained, right, with respect to this two data set. So I would like to save this object. Now, what is there inside this object? Nothing. MC. That's it. With y is equal to mx plus c. So value of m and value of c. That's the only thing that we have inside this particular object. Nothing else we have. So here I would like to save this object inside one of the physical file, so that let's suppose if you have to do if you have to do a deployment, or maybe you don't want to build a model, you don't want to like write all of this code. So what I will do, I'll just share this particular file with you, and you don't have to even train or you have to do anything. Just pass a data, get the result. That's it. Simple, right? So here what we can do is, so maybe I can try to call pickle dot dump over here, right? So pickle dot dump I can try to call, and what I'm supposed to, or what I'm trying to dump, I'm trying to dump my linear object, right? So this linear object where I'm trying to dump, so inside this file. So maybe I can try to open up this file, right, that I have created. into write mode and execute. Now if I'll go and check, right? So what is the file name which I have given? Linear underscore regression dot sav, right? So here you will be able to find out in this location. So linear underscore regression sav, this is a file which is created just now, right? It's a 452 bytes of the file. Now, if I'll ask you a question that if my data set is going to increase, let's suppose there are 200 rows or records. If I'm going to take 20,000 records, what will happen with this file size? Is it going to increase? Yes, right? It is supposed to increase. Yeah, there are some people who are saying, yes, it is going to increase. Okay. And most of you are saying, no, it is not going to increase. But yes, there are some people who are saying that it is going to increase. Now, why it will increase? First of all, you are just storing. I told you, right? What you are storing inside this SAV file. Y is equal to mx plus c. So whether it's a 2 record or 2000 record or 200,000 record, right? Have I changed the equation? No. Now there is another case. Let's consider, right? Let's suppose I have as of now, one column, one X and one Y, right? If I'm going to take maybe a 100 column, 100 X, X1, X2, X3 till 100, and one Y, for sure one Y will be there, right? So if there will be like 100 number of features, is it going to increase in that case? Yes, it will increase, right? Equation is changing, right? So now you will be having like a M1, X1, M2, X2, M3, X3. So equation, but it is not going to like change by a huge volume, because you're just changing the equations, adding some of the parameters. So it is just going to like increase by a small fraction. But yes, in that case, for sure increase, right? If number of features are going to increase, in that case, size of the file will increase a little bit, because at the end of the day, it is just trying to store the equations. If it is equation size is going to like increase or decrease, only in that case it is going to affect this particular model. Otherwise, it is not going to affect. It is not having any kind of a relationship with respect to the number of record, number of feature. Yes, there is a relation. So this is like a model that we have created, and now this physical file I can share with any one of you, right? And you all will be able to do a prediction. You all will be able to load this model, right? You all will be able to load this model, and you all will be able to do a prediction by passing some sort of a data set inside this one. So first of all, let's try to do one thing. So let's try to do some sort of a prediction out of this model. So this is the model which I have created in later stage. So we'll try to load even this file. So let's suppose this is like a equation that we have, right? Or this is the object that we have. So maybe I can try to call linear dot predict. Now here, if I'm going to pass, so what value I'm going to pass? Can I say TV? So let's suppose if I'm going to pass something like $45, right? Now value error. So yeah. So if TV advertisements, right? So we are going to spend $45. So in that case, sales will be equal to 9.17. This is the prediction, or this is a result which I'm able to see. And again, it's coming from the same old equations that we have established. So even by doing this calculations manually, so you will be able to understand the same thing, right? So y is equal to 0.047x plus 7.03. Just try to give a value as 45 over here, right? You will be able to see a same result. You can just verify for just for the cross checking, right? You can try to verify it, and you will be able to see a exact same result even in that particular cases. So this is a small instance of the model that we have built, and we are just trying to perform these kind of operations, nothing else and nothing much. So this is how we can try to do a prediction, right? So if we have to pass a multiple values, so yes, we can try to pass even a multiple values, and we will be able to get a prediction. So maybe if I'm trying to pass 67, 67, 78, one dimension came, size 1 is different from 4. No, not in this way. So let's suppose someone has given me that this is the list, and inside this list I have like a 4 comma 5 comma 6 comma 89 comma 34 comma 45 comma 67 comma 23. So this is the expense, right? Someone has told me that, okay, fine, so this is the like an expense which I'm going to make on a TV sales. Can you please give me what will be the sales, right, for each and every expenses? So that is completely fine, right, for I in L. And I can try to pass all of these values inside linear dot predict maybe, right? And one by one, so I value I can try to pass and predict of I, and it will be become 4 over here. Yeah, so this is something that you will be able to get. So for all of this like a TV advertisement investment, right? So if I'm going to invest $4, then in that case this will be the sales. $5, this will be the sales. $6, this will be the sales, and so on. $23, so this is going to be a sale which I'm going to make. So whether it's a one values or whether it's a multiple values, so for each and every values I will be able to make a prediction, right? So simple, we have to call linear dot predict and my work will be done. So anyone who is having any kind of a doubt, are we able to do each and everything? Yes. So I think we are like good till this particular point. So we all are like aware about this particular fact, that how we are trying to find out this coefficient, or how we are trying to find out any such kind of a things, what kind of relations we are able to draw out of this one. So each and everything is pretty much clear to each and every one of us. Now what we can do is, so maybe we can try to like do a little bit of more on top of this one. Why it is asking for a 2D inputs? Because at the time of training of the data, so we have given a 2D inputs, and by default it takes a 2D input. Scikit-learn X vector that we are supposed to pass, so it takes a 2D vector by default, and that is a reason. So it is asking me to pass 2D inputs. There is no other reasons. So any question, guys? So I think successfully we all are able to build our very first model, right? And we are able to perform this kind of operations. Okay, Bijoy has pinged me this code, m is equal to 0. Fine. So, okay, that's great. What is the data set that you have taken? X. So what is this X in your case? Send the link again. Okay, which link? Write once and use many times. Yeah, okay. So this kind of a code I'm going to ask you to write. Same data set. So okay, so I'm supposed to like place these things by your df length of this one. Okay, so TV index you are saying. Fine, we'll replace. Okay, so yeah, this is a code again that we have received from Sagar, and this is a code from Bijoy. And what they are trying to do is, so they are trying to do this kind of a calculation manually. So they are trying to calculate like m, they're trying to calculate b. So each and every time they're trying to adjust these values, right? But here in this implementation, in Bezoar's implementation, so I can clearly see that he has not taken a differential, right? So he's not trying to find out that when this one will be equal to a 0, because based on that, so we should keep on changing the values. Otherwise it will try to give you a final value of m and b that you will calculate based out of your data set. So this is the problem with this code. So differential factors you have to consider, right? There is a function to find out a differential as well, the way we have done yesterday. Now let's try to look into this one. So here for this one range, that is fine. Gradient descent. Okay, this is the code for the gradient descent. Cost is equals to, okay, so cost you are trying to find out, and you are trying to change m alpha by length. Fine. So you are trying to make this one as a variable one. So again, this is a picked up code from somewhere. I remember, because here you are taking a variable of, or you're just like a trying to take a eta which is divided by length, right? Alpha by length, and alpha value you have already like fixed it 0.8. So learning rate is equal to 0.8 by total number of the data set. So if data set is going to change, so your eta value is also going to change. This is what happens in a simple gradient descent, right? Even without changes you can try to take it. That is like a fine. This is what we do. But yes, differential, it's a basic of gradient descent. Actually it's not a differential that you are trying to consider over here. 0.8 is much higher. Yeah, so that's the reason. So he's trying to do one thing, right? So he's trying to divide these things by length of the total data set, right? So he's trying to calculate a length. So let's suppose if your data set is very high, so in that case means number of records are very high. Let's suppose I have a 10,000 records, 10,000 number of the rows. So in that case your learning rate will be very low, means I'm looking for a very slow changes. But again it is going to give you a disadvantage in terms of like it will not try to adopt like easily each and everything. Going forward you will try to understand, we all will try to understand what is the difference between a different gradient descent. There is something called a stochastic, there is something called as a mini batch, there is something called as a batch gradient descent. Again inside that there are different kind of a gradient descent algorithm you will be able to find out, like Newton's equation, RMS prop, ADA grade, ADA delta, Adam, right? So we'll try to study all of those things in our deep learning classes. Those are like a very interesting topic. Okay, so I think basic of these operations we all are able to perform, right? We are able to build a model, we all are able to like build an equation. Model means nothing but just an equation, right? We are able to save all of this model physically, right? We all are able to do it. So physically we are able to save it. We can do even a prediction of all of these model. So whatever models that we have saved, we can try to even calculate r square, right? Or we can try to calculate some other factors or some other things by which I will get to know, okay fine, so what is the accuracy of my model. So all of these things are pretty much easy, we all can do it. First of all what we will do is, so we have saved a model over here, right? So let's suppose this is a model that we have saved. Now if I'll ask you, or if I'll give you this model, and if I'll ask you that, okay, can you please try to do a prediction out of this one, you should say yes, I will be able to do a prediction. How you will be able to do a prediction? So pickle.dump for saving a model. Now I can do one thing. So pickle.load maybe, right? So pickle.load, what I'm supposed to load. So try to open up your file. So what is the file name, right? So whatever file name that I have given, file. So this is the file that I have to like open in maybe a read mode. I can try to open it up. So this will try to create again a same object that we already had, right? So maybe I can try to name these things as saved underscore model, and we are trying to load it. Now, same thing, right? Same thing, save model dot predict, right? I can try to pass a data inside this one. I can try to pass a data 45, let's suppose, and I will be able to get a prediction. Yes, it's a very easy thing. So this time, if I'm going to share this particular model with all of you, right, which is a physical file, you don't have to do all those things which I have done in terms of a training. So you can just try to give this particular file to anyone. Anyone will just write this 2 line of a code. 1 line, 2nd line. Work is done. So you can try to reuse my model in your system without even doing a training. So whenever we used to build a model, so there will be a testing team, right? So testing team will try to take this particular model and they will try to test it with a different kind of a random testing, or there are multiple procedures that we used to follow. So I think when we will get into our DevOps classes, so we'll try to understand even those things. So what is the testing procedure that we used to follow? It's a lengthy one, right? So we all will be able to find out each and everything in a easiest possible way, right? Now let's suppose we all are supposed to find out accuracy, how accurate my model is. So we are able to do a prediction, that is fine. With respect to a model object, with respect to a physical file, that is fine. We are able to create a physical file, we are able to load a physical file, we are able to do a prediction, that is fine, right? Now my idea is to find out that what is a score of this model, or what is accuracy of this particular model. So what I can do is, so maybe I can try to call a linear, this was the model object, or maybe I can try to call a saved model. Both is because same, right? Just like an object type is different. So I can try to call this one, and maybe I can try to call a score over here. I can try to pass my X data and a Y data and then execute. What is the score of the model? So can I say that accuracy of my model is 61%? Yes. So it's the same, like it's again a very easy one, right? So pass a data, although this is not a best way to pass a data, because we have passed a same data which we have used for the training, right? At the time of finding out the score, right? So we always try to find out what? So we always try to find out, or we always try to give what? A separate data set, right? We always try to give. It's not like we are going to give a same data. This is not a correct procedure, but as I said, this is just a first class. So these things are fine. In second class, this is not going to, we are not going to repeat the same thing, right? So we'll try to follow a complete different procedure from top to bottom. So whatever procedure that we have learned, it's just to connect with our studies discussion. That's it, nothing much. Yeah. So now if I would like to know that what it is trying to do inside a score. So can I say that return a coefficient of determinant of R square of a prediction? Yes. So the coefficient of R square is defined as 1 minus UIV, right? So can I say that it's a same thing that we have studied yesterday, R square? Yes. And R square is nothing but 1 minus residual summation of a square divided by total summation of a square. So here it's written, so 1 minus UIV, where U is a residual summation of a square. And what is the residual summation of a square? So can I say that Y minus Y prediction square, right? Summation of that. And what is V? So it's nothing but total summation of a square. So Y minus Y mean of a square, summation of that. So can I say that whatever we have studied yesterday, theoretically, line by line, we are able to connect, even in terms of coding? Yeah. So this is a score that we are trying to calculate. It's actually giving you your R square statistics, exact formula that we have applied. And same thing is applicable even over here. You can even calculate it manually. There is no issue. So like it's a very simple, right? So yeah, so score is going to be like always in between 0 to 1, right? So this is the score that you will be able to see, or you will be able to get all the time, right? Now, so there are again many things and multiple things that we can try to perform on top of this one. There is something called as regularization. There is something called as statistical operations on top of this. We can try to apply, which we will try to apply maybe in a later stage, right? We have to learn about like different kind of regularization, like raised L1, L2, raised lasso, elastic net, polynomial regressions, right? And yeah, many more things plus deployment. So maybe we can try to explore all of those things one by one. But till this point, is it fine? Can we say that a score 0.61 is not so good? Yeah, we can say it clearly that it's not at all good. My data set is not showing very much like a relationship in between. Yeah. So I think we all are able to connect, right? So whatever we have discussed in our yesterday's class till yesterday, right? We all are able to connect easily. We all are able to understand this particular part. 95%, 80%, why 80%? In today's class, we have not discussed anything. Just like a simple one line, two line of code. Right? Can we see a line graphically? We can see anything. See, it's just a code, right? So if you are able to see a data, get a data, if you can write a code, we can do anything, whatever we want. Just a code. It's not like someone is going to tell you like, okay, fine, so this can be done, this can't be done. Everything can be done, and everything is a white box. We can see each and everything. We can alter each and everything. Coding practice not done. Great, Rohan. Okay. So are we good with this entire like coding stuff and everything? Yeah. And I think we all know. So what is the basic steps we have to follow to build or to create a model, and how to share this particular model with anyone, right? Okay. Now there is a small task for all of you, which you all have to submit in next like a 1.5 hour or 2 hour, right? Within that, so you have to submit this particular task immediately. And what and all operations you have to do, I'm going to define, right? How you are supposed to write that, I'm going to define. So let's try to talk about this one. Where to submit? You have to send a mail. I think we all know the procedure, right? For all of my tasks, you have to send a mail. I think we all know where to send a mail. Please give more time, need a break. No, so just write a 20 line of code. Why do you need a time? So just you have to write 20 line of code, right? Okay, so let's talk about it. I'm going to share this particular like link with all of you, right? So yes, this is a link. Okay, fine. So this is a link which I have given to you, all of you. Now I'll explain you what is needed over here, right? So this is a link. I think you all have a link, right? We need to figure out to write those 20 lines. No, Pratik, it's fine. Under pressure, right? So our productivity always like increases, right? So it's good to like work under pressure. If I'll give you like a 10 days time, you will work, you will do the same thing, right? In 10 days. So instead of doing in 10 days, let's do it in 10 minutes. Okay, you are very much new. I think mail ID is available in your dashboard itself. So in every video, so you will be able to see a mail ID. Query at the rate I'm not AI. That's a mail ID. It's mentioned to everyone. Everyone knows about it. Yeah. And this is like a pretty much common for all of us. I will try to give a deployment link in 1 hour. Yeah, see. So Ketan is a person who is telling me that he will give me a deployment link, not only just this one. So this is called as guts, right? So he's telling that he will not only solve this one, but he will deploy. So this is the kind of enthusiasm we are looking for the previous model. Yeah, that will be like shared anyhow within 24 hours. So when like the recording will be uploaded, so these things will be available. That is not an issue. Now let's talk about a task, guys. Yes, one by one, quickly. And yes, there are some customized tasks. So I'm going to give you this data set. This is nothing but it's a A141 predictive maintenance data set. So whenever we try to maintain, let's suppose some of the ships, some of the aircraft, or maybe some of the vehicles or something, right? Or maybe some of the machinery. So that is something called as predictive maintenance. We all do all those kind of a maintenances, right? And again, this kind of a data set helps us to find out some sort of a fault in our vehicle. So let's suppose if I'm talking about my vehicle, so when I go for a servicing, so what they do is, I have seen these guys, like what they used to do is, so they used to because there are so many sensors, so they try to open up a bonnet and then they will try to attach a computers with those sensors, and they will try to load or extract some of the data set from my vehicle, and then based on that, so they try to do some analysis, and then based on that, mechanic will try to work, right? So in predictive maintenance, this is what happens. So we try to pull out a data set, we try to do some analysis, we run some model, we try to identify, okay, fine, so where is an issue, and based on that issue, so we can try to fix all of those issue, or maybe continuous data set I'll keep on getting, and then I can try to send a notification to a user saying that, okay, fine, so this part, there is a high chances that this part is going to fail, so it's better to replace this particular part. So this is a kind of applications that we use to build. I'll talk about this kind of application more and more because I have a personal experience in terms of working with this kind of applications when I was a part of Verizon telematics division, where we were working for an autonomous car, some of the components. So first of all, solve this one. Yeah, because this is the very first class for you. So here, predictive maintenance is like somewhere we try to pull the data, and then for some of the machinery, and then I will try to test it, or will try to predict or forecast that, okay, fine, so which device needs what kind of a replacement, or where values are going beyond a threshold or going like a very, very low. So in this data set, this is something that you will be able to find out. Now, if I'll try to go to this data folder, a link I have shared with you. So here is a data set, AI 4i 2020 CSV, right? So just click over here and download this data. Yeah. So let's suppose if I have downloaded this data, so I'll try to open up this data. Now, if you will try to check what is the total number of the data set, so it's a 10,000 records that we have, 10,001, because we have a one header column over here. Now, if you'll start looking into this data, so there will be UID, there will be product ID, there will be a type of data, there will be a air temperature, there will be a process temperature, there will be a rotational spin, RPM, right? Torque will be given, top wear will be given, right? Machine failure will be given, so whether there was a machine failure at this level or not, right? So somewhere you will be able to find out 0 0 0 0 most of the time. Somewhere you will be able to find out 1, means here machine has failed, right? So here machine has failed basically. So TWF, SWF, PWF, OSF, RNF. Now this full form is not given over here, but full form is given to you. Where full form is given? So here full form is given. So if you will try to read out descriptions about this data, so for everything full form is given to you, right? So let's suppose we will try to read out, because this is how we always proceed, right? So we always try to proceed ahead with this kind of things, and there are many tasks which we can derive out of this data set itself. 10,000 number of records that we have. So what kind of a task I will be able to derive? Let's try to understand. So here inside my data set, UID is given. What is the meaning of UID? So meaning of UID is unique identifier ranging from 1 to 10,000. So this is the unique indexes or unique user identification number which is given to me. User ID is given to me. Then product ID, content of letter. So after this, what is given to me? Product ID is given to me. And what is the meaning of this? So consisting of a letter L, M or H for low, 50% of all product, medium and high. So H is for high, M is for medium, and then L is for low, as a product quality variants and the variant specific serial number. So whichever is having a low quality, so yes, there is a low type and it's coming from here. So initial letter is representing that whether it's a low or high. So again, this is the internal numbering that someone has given, or internal naming convention that someone has given at the time of defining this particular data set. So this is the meaning of product ID. Product ID is having a specific meaning. L means low category, and then it's a number which is given to us for a different product ID, right? Okay. Now here air temperature is given to me. So generated using a random walk process, later normalized to the standard deviation 2 to 3K, 300K around. So what is the air temperature for this particular product? For this particular product, what is the air temperature? What is a process temperature? What is a rotational speed? So let's suppose if I'm trying to test some of the wheel, or maybe some of the gear shaft, if I'm trying to like test, right? So whether what is the quality, so medium quality, low quality, high quality gear shaft, I'm trying to test, right? So medium, low, high quality. What is air temperature, what is a process temperature at that point of a time, what is the rotational speed, right? What is the torque that I'm able to see, what is like a tool wear I'm able to see over there, what is whether it has failed or not at this inputs, at these inputs it has failed or not, because somewhere you will be able to find out there is something called as one, right? There is something called as one, means if this is a situation, right? If this is a situation, yes, it has failed in this particular situation. So here maybe we can try to find out the pattern that why it is failing, and maybe I can try to learn something out of this one, right? So if same kind of a situation is going to happen again, so I can try to notify my users that okay, fine, so it has failed. So understanding of data set is very, very important, right? So process temperature is given, random speed is given, torque is given, tool wear is given. A tool wear, so what it is trying to say here, so tool wear, so 0, 3, 5, 7, 11, 14, 37, and all those things, which is again a numbers which is given to me. So tool wear is nothing but it's a meaning the quality variance, so high, middle, and low. So 532 minutes of tool wear to be used in a tool process. So 532, high, middle, low. So this is something which is mentioned over here, so which is again one of the inputs which is given to me, again depends upon the data like a type which we already have. So tool wear minutes is given to me. Now here machine failure, so label that indicates whether machine has failed in a particular data points for any of the failed models are true. The machine failure consists of 5 independent failure mode. So tool wear failure, TWF, heat disappoint failure, power failure, overstation failure, and random failure. So here all of these things are just a failure. So in this condition, right, on this condition, which one is going to fail at what point of a time, this is something which is given to all of us. So maybe let's suppose if I'm talking about this data set, right? So this data set has failed here and this data set has failed here, but in other processes this data set has not failed, right? So this data set has failed on PWF and this data set has failed on like a TWF. So PWF means what? So PWF is nothing but power failure, right? And TWF is nothing but tool wear failure. So this data set has failed at this point of a time, and at another point of a time this data set has failed. Okay, so this is something which is like given to me, right? So which is like given to me. So here what we can try to do is, so I have to build a model. There are like a 10,000 record which is given to you, right? So I have to build a model, as we have learned a regression things, right? So I have to build a model, so where if I have to check, so I'm trying to build one of the procedure where if I would like to know that okay, if data set is going to fail at this point is equal to 1, 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 then what should be a air temperature? This is, so your y column is supposed to be a air temperature. This is what I am expecting. Your y column should be a air temperature, your x column should be anything, any of these things, right? So you have to find out, you have to figure it out. So your x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, so these are your feature column which is given to you, right? What is my expectation? So let's suppose you will give me a model, right? So if I have to test that, okay, so tool wear failure, hardware failure, or pressure failure, or something like that, right? So I'll try to make these things 1 1 1 1 1, and then I will try to predict, okay, fine, so at this temperature or at this air temperature, this is going to if like this is going to fail, or maybe when tool wear failure will happen, when this points will be given to me. So based on that, I can try to test it. So this is the simple basic model which I'm expecting from all of you. So regression point wise, you have to give me a final air temperature. So you have to regress with respect to air temperature. Is it fine to all of you? Are we able to understand the problem statement? So what is the final goal? What is the final objective that we have? Yes. Okay. Now you have to load this data, right? First of all, I think you all will be able to do it. There is no issue. After loading a data, you have to find out that there are certain points which you have to consider. Point number one, start writing it, right? So first of all, data loading, load a data. So there is no issue. You all can do it, right? Just a one line of a code. Second line is, so after loading a data, so try to do a profiling of the data. Profiling of a data. Third number is write your analysis of data, right? So whatever observations you have, whatever things you think that, okay, fine, so this is available in a data, this is the relations that is there inside the data, this is like a deviations of the data, this is the variance of the data, this is the normalization of the data. So whatever relations you are able to find out, just do it, write it down. This is the observations I'm expecting from your side in pure UTF-8 character English, right? UTF-8 is called as English actually. So in UTF-8 character, I'm expecting your observations, right? So like when I was trying to explain a pandas profiling, so I explained you so many things, right? So like what is the coefficient, what is the correlation, whether one thing is dependent on others or not, whether there is some relationship or not, right? So it is already written in pandas profiling, but what is your observation? There are many stats, many graphs we used to get in a pandas profiling, right? But after looking into those graphs, you are going to make some decision, right? So this is what I'm expecting from your side, right? And yes, you can try to show me like a pandas report, and with respect to that report, I'm looking for like a procedure, right? So what is your observations? What is your thought process? What are you are able to observe? It's not like you will just generate a report and send it to me. This is the report, read it out. No, I'm not expecting that. Let's suppose I'm not a person who understands your data. I'm not a person who understands all those relations, right? So explain me in an English word, simple, right? So this is what I'm like expecting. Fine. So in the same notebook, you have to write it down. Write your own analysis of the data. Then fourth number is, so if there is some NA. So if there is some NaN, in that case, go for imputation. Then fifth number point is, so if your data set is not normal, then handle it. Sixth number is check multi collinearity and make a decision based on that. I think we all know what is the decision that we are supposed to make over there, right? Okay, someone is saying problem statement, please. What I was doing then, like since last 15-20 minutes, I think I was trying to explain the problem statement, right? Okay, so check multicollinearity. Fine. This is something that we have to do. And after checking a multicollinearity, after like doing this basic stuff, basic operations, so what you have to do is, so you have to like build a model. Build a model. So as of now, you don't know like many of the model building. So for sure, linear regression is the only one that you are going to use. So build a linear regression model on top of that. Then point number 8 is, so once you will be able to build a model, save it, right? Point number 9. Model accuracy. Point number 10 is, so save it, model accuracy, and then 10 test case. 10 test case means, so sometime this value will be different, this value will be different, this value will be different, and based on that, write 10 test cases. Is that okay? Fine. So this is the final result which I'm able to receive, and the original result will be this one. So just observation, simple 10 data. Expecting that you will try to pass 10 data set. So 10 records, and then for all those 10 records, so in parallel to that, you are going to give me a final report. That okay? Fine. So this is a data frame. I have passed this data, and this is the result. This is the prediction I'm able to see. Right now, so while doing this implementation, all coding procedures that we have already discussed must be applicable by default. So we are not supposed to talk about it, right? Because when I was talking about those things, I told you very clearly that going forward, this is from Nivriti, I think. Vidyut, I think, and Nivriti, yeah, both. So they have just like pinged you all those things, right? All these 10 things. I just like pinged you guys. Okay. So yeah, Monica has also given me. Fine. So by default, when you are trying to do something, some sort of a coding, even if I'm not going to ask, you have to write your code by using a standard procedure, right? So yes, do it and send it to me, right? So what is the time as of now? So I think it's 4:54 IST PM. So by 7, I'm expecting this result from all of you. From 8 p.m. IST, I have live YouTube live, so where I'm going to make some announcement, right? I hope you all have seen my video, right? So kind of a Raksha Bandhan gift. So for all sisters, 51 like selections I'm going to do. So I'll try to make an announcement. Then feel free to join that live sessions. I'll be happy to discuss, right? So I'm just going live. So if you have any kind of a doubt, concern, confusion, so yeah, no git for us. Yeah, so I know this is the question you are going to ask. So for all of you, this is a gift. Love. भाइयों को छोड़ दिया सर, तो वो होता नहीं है ना, वो मतलब लाइक भाइयों लोग के लिए कुछ so it's like that. Okay. So fine guys, just try to do it, right? And let's connect at 8 p.m. IST, okay, in my live session. लड़के लोग लाइव बर्बाद. No, it's not like that. Yeah. Anyway, thanks for this gift. Thank you. Thanks everyone. Thank you so much. You saw the profiling code once. Okay, profiling code is this one. This is a profiling code. I think this is the implementation, right? Yeah. So simple. You have to call a profile report. See, I'm just doing one thing, right? I'm just trying to like import this profile report, and then I'm trying to call a profile report passing my data frame. That's it, nothing else. So profile report, I'm trying to import, and then I'm trying to pass a data frame. That's it. If you're looking for everything in this kind of a window, so in that case, you can try to do like pandas.to widgets, and you will be able to get it. Yeah. Data set link wise, okay, so this is a link. Okay, this is a link. So what I can do is maybe I'll ask my team immediately to update this link inside your dashboard, right? And here is a link. Again, I have pinged you this link. Yeah, Nilesh. So see, this is not a way to write down these things, because I can see in your code you are trying to use minus of 2 and DM and DC. So no, old DM and new DM you have to use. So okay, L into DM you are trying to use for this update purpose. Yeah, this will not give you, this will give you approximate result. No, this is not going to give you a correct result, Nilesh. Yeah. So I think you all are able to get a link, right? Anyone who is facing any kind of a challenges with the dataset link? So I think we all are okay. We all are good with respect to a dataset link, right? So try to build a model. Those who have done something in advance, right? Those who have already gone through my deployment models and everything. So deploy it. Yeah, because I know some of you are going in fast track. So those who are going in fast track, I don't think that you will face any kind of a problem, any kind of issues. Yeah, we need to send a notebook. You can send me a notebook, you can send me a .py file, right? I don't have any kind of issue. I'm completely okay with both. But yes, remember, so if you're doing a pandas profiling in notebook, you can easily do it. In case of a PyCharm, so you will have to install an extension. It's possible in PyCharm, but after installing a extension. So just feel free to do it. I was trying to predict air temperature versus TWF. No, so you have to consider all the columns. So X column wise, you have to consider all the columns except your ID column, UID column, and except your UID column, product ID column. So you have to consider all the columns. So it's kind of a multi-linear regression problem which I have asked you to solve, where you have to regress with respect to a multiple variables. Or even if you are going to deselect, or if you're not going to select any of the column, so in that case you have to give a reason that okay, this column I have not selected as my feature column. Yes, so Y is basically a air temperature and X is basically a remaining column, all the rest of the column. So the yes. So any other question, guys, for me? Anyone? We have to include a type column also. So type column, no, type column, I don't think that you will be able to include. So type column is not required. Otherwise, you have to like convert this character into a numerical representation. So we have not discussed encoding part so far in your classes. So this is not my expectation. Once I'll discuss encoding part, different like a type of encoding, then I'll give you that problem. What about product ID? No, product ID you are not supposed to include. It's completely fine. See, you have to observe, right? You have to identify that what is a relations. If there is a relation, in that case, you have to include. So even in my case, there was an unnamed column and I have not included unnamed column in the similar way. So this is a kind of a decision you have to take. Please send us a Jupyter notebook, which you have discussed. Yeah, so I think we all know it will be uploaded within 24 hours along with your recordings, right? So it will be available in your dashboard in next 24 hours. This is what we do always. Pandas profiling is not working. I think we have discussed Pandas profiling long back, right, Jiren? Still not working for you? Please show a code. Let me ping you a code. Okay, so simple import over here. I mean, like only this part. So this is import. And once I will be able to import, so what I can do is I'm just trying to pass my data frame. That's it. Nothing else I'm trying to do. Need to install first if someone is using a first time. Yeah, so for sure, if you are using these things, because I believe Pandas profiling we have already discussed, right? So linear.xy is not working. So yes, max to max, you must be getting an issue like a 2D issue array problem. So you can try to do one thing. So you can try to use this bracket and then it will be fine. Chris Naik channel is there for a Pandas profiling. Okay, you can watch it, but I'm like, we have already discussed about Pandas profiling, right? In our class itself. And it's not nothing. So just within a 30-second, we can do it. We all can do it. I install Pandas profiling, but while I'm importing it, this giving me an error. You have to like restart. You have to restart if like there is some issue with the installation. So sometime with some of your system, it is going to give an issue. Will you accept it if we send after 7 p.m.? I don't have any issue, but yes, try to do it within a time limit. I think that's my expectation. Temperature is a target column. Yes, exactly. So I told you air temperature, not this temperature. So air temperature is my target column. This is my Y column. Okay, so Hitul has pinged me. This is Pandas profiling installation code. I'm not able to copy the content that you are pasting, is it? Because Zoom copy is disabled. No, guys, from my side, I think I have not disabled. But let me do one thing. Right, so I have another way to share this code. Okay, so go to this codeshare.io, right? And codeshare.io, type it if you want. And over here, so I'm like going to share each and everything. So I think you will be able to see it. So this is the codeshare.io. And let's suppose if I'm going to ping. Okay, so unnecessary, don't type over here, right? This is not going to help you out. So anyone can share their code here, but let me do that. One should be done after setting XY as a per your requirement. You can try to like do a pandas profiling before that, right? So whenever you try to load a data set, so at that point of a time, you can try to do that. Yeah, so even this code of pandas profiling is going to work. Just try to mention hyphen users so that on a user label, so it will be able to install it. Okay, so fine. Let me ping this one dataset link. Where is this dataset link? This one. And yeah, so this is the dataset link which is available over here. So you all can see this codeshare.io. You can just type this code and you will be able to access same screen which I'm trying to access. And see, this is what happens, right? So someone is like going to delete it. Yeah, so you all can go here, you all can download, that's completely fine. Okay, so I think we are good, right, everyone? Email ID on which we have to send a code query that I'm not. Yeah, yes, Priyanka, exactly. Can I expect some Raksha Bandhan celebration if I submit first? Okay, yeah, you can try to do it, Sandeep. Let's see. Okay, so fine, guys. I think we are good for today, right? Just try to build it and try to correlate whatever we have discussed till yesterday. Nothing is black box, right? Everything is doable. So yes, try to submit it within 2 hours by 7 p.m. IST. I think it will be better. It will not even take half an hour of time. So I don't think that you have to sit till like a 7 p.m. IST. Maybe if you are going to sit for half an hour, you can do it, right? So this is the only expectation that I have from my side for today. And in next class, so I'll try to extend our same classes. So where we will try to learn this linear regression with some other data set, with some complex data set, and we will try to follow all the procedures, all the EDA procedures we are going to follow, data selection procedure, data engineering procedure we are going to follow, data normalization, standardization, all those things we will do, imputations we will try to do. Then we will try to build a model after doing train, test, split, and many more things, all the standard procedure. And then we will try to learn a polynomial regression plus regularization, risk lasso, elastic net, and all those things. So till then, what I believe is like you are supposed to be good with each and everything. Yes. And with that, thank you so much, and see you again in your next class. And immediately, this data set which I have given to you, it will be available inside your dashboard. So those who are facing any kind of a challenges with respect to a data set, you all can download it. Plus, as I have mentioned in my today's class, squad part, right? Do remember, so whatever work you're doing, I have received some of your work, right? Yesterday I have seen some of your mail. I'm yet to respond back to some of your mails. So in this similar way, so I'm expecting this kind of a response from all of you, because this entire week, so I'll keep on creating different squads for different projects groups, right? So where me or my team will monitor each and every work that you are going to do going forward. Yes, and they will assist you, and they will try to push you as hard as possible to accomplish your task in your internship. Yes, with that, thank you so much, and see you again in my next class Saturday for sure. But work on your internship, right? We are getting involved in each and every projects, those who are going to do a project for sure. So those who are going to showcase some of the improvements, so now we will be engaged from our side directly in your project, and we will start taking an update from all of you. But at the end of the day, you have to work. We'll just guide. This is how internship happens. Yes. So with that, I think this was the expectation, right? And many of you were saying that, okay, fine, so this is what, so this, all these things are planned, so it's not like something is unplanned or something. But yeah, everything happens in a phase wise manner. This is what we do always. So with that, thank you so much, guys. And please add me to a squad. I'm not going to add anyone. You are supposed to send me a work. Show a work, then it will be created. You're not going to show me a work. I'm not going to add. Very simple, right? I'm not going to add you in some squad or something. No, I have already given you a link. You can join a project. And if you think that I will not work and then someone will include me in my project, that is not going to happen. Internship means you have to work. So you have to showcase. Very simple. Right? Don't even ask me if you're not working. Yeah. So fine, guys. What about individual project? Yeah. So you can send me individual connection. You can work. Okay. With that, thank you so much, guys. Thanks. See you again in my next class. And happy Raksha Bandhan, by the way, to all of you. And yes, I will be live at 8 p.m. IST. So let's come over here for our discussions, some off-topic discussions. So if you have to do, so yes, you all are welcome. Yeah, at 8 p.m. IST on my channel. With that, thank you so much. Thank you.